All right, good afternoon, everybody. Welcome to class. So after the test, I hope the test was, went smoothly. All right. So, I had a lot of copies to grade. That is the reason, probably I'm going to grade your test, between now and Sunday. Okay. I have all my classes. I did tests, so I have a lot of tests to grade. Okay. So we're going to continue the transformation of graphs. And we saw last time, we saw all the transformations, right? We saw when to go up, when to go down, right, left, when you flip over the x-axis, when to flip over the y-axis, right? And then we saw when to stretch and to shrink the range, right? We saw that, and our last transformation will be when to stretch and shrink the domain. That's going to be our last transformation in this topic. Okay, so let me share my screen. So that is the last one here. So shrinking and stretching the range, the domain. The domain, right? Which is a horizontal shrinking or stretching. Horizontal shrinking or stretching. Okay, so let's give this example right here. So this is my function right here. That is f, okay? Okay, tell me from here, what is the domain of f? What is the domain of f?
-2, 4.
Thank you. Is -2, 4. Is the interval closed, -2, 4 closed, right? Okay, let me now define a new function, g of x is equal to f of 2x. That is my new function, g of x is f of 2x. So basically, the 2 here, the multiplication by 2 is on the x itself. You see, this attacks the structure of the function f because the variable here changes, okay? So that is slightly more complicated if you do 2f of x. You see, when you multiply f of x by 2, this right here is less complicated than when the multiplication is on the x itself, because here it does change the domain itself. Let's see what effect it has on the domain. Let's see. Okay, so look, here, because the domain of f is -2, 4, this tells me x has to be between what numbers? For f, x has to be between -2 and +4, right? Okay. In order for us to be able to find f of somebody, they have to be between -2 and 4, right? For instance, can we find f of 5 from this graph? Can we find f of 5?
No.
5 is not between -2 and 4. Can we find f of -3?
Yes.
F of -3. Can you find f of -3?
No.
-3 is out of the interval, right? You see, for us to be able to find f of somebody, they have to be between -2 and +4. They have to be, right? Okay, so look, which means if X is in the domain of G, right? For X to be in the domain of G, the right side has to make sense, right? You agree with me? The right side, for this one to make sense, this side has to make sense. But tell me, for f of 2x to exist, 2x should be between what numbers? For f of 2x to make sense, right? 2x should be between what numbers?
It must be in the domain.
Between -2 and +4, right? Okay. That is, you know, for f of 2x, f of whatever makes sense if that whatever is between -2 and 4, right? You see, f of this stuff right here, f of delta makes sense if delta is between -2 and 4, right? F of epsilon makes sense if epsilon is between -2 and 4. You know, it doesn't matter. So f of 2x makes sense if 2x is between -2 and 4, right? So for x to be in the domain of G, 2x has to be in the domain of F. Okay, which means 2x has to be between -2 and 4, which is the domain of F. Okay, so if 2x is between -2 and 4, this gives you less freedom for x, right? Okay, this gives you less freedom for x. Actually, x has to be between what number then? When you divide by 2 everywhere. So f has to be between
-1 and 2.
And 2. You see? So which means what is the domain of G then? Which means the domain of G is only -1 and 2. So compare the domain of G with the domain of F. What happened? Did it shrink or did it stretch?
It shrunk by 2.
It shrunk by 2. Thank you very much. You see, what happens here is when you multiply by a big number inside with the x, your domain shrinks, your domain becomes smaller, right? Which makes sense because it gives less freedom to x, right? So the domain of G, instead of -2, 4, the domain G is only -2, 1. So basically G will be from here to here only, right? -1, 2. But the range, look, the range will be the same, right? The range will not change. That's going to be G, right? It's going to be the same range, but the domain will shrink, okay? When you multiply by a big number, the effect it has is to shrink the domain, okay? So if we have multiplied by a bigger number, so let's say now we say h of x now, let's say we say h of x is f of x over 2 now. What's going to happen? The domain of h, will it be bigger or smaller than the domain of f? Let's see.
It'll be bigger.
It's going to be bigger, of course. Thank you. Because this one right here, x over 2, has to be between -2 and +4. Now to get x by itself, we have to multiply by 2. So we have to multiply by 2, multiply by 2, multiply by 2. What we get? We get -4 less than x less than 8, right? You see, the domain of h will be twice bigger than the domain of f. It will be -4, 8. As if we multiplied the original domain by 2 by 2, right? So this example shows us when we multiply the variable x, inside by a big number, it shrinks the domain. When we divide, it stretches the domain, right? So, and that, you know, if you were doing more math in this topic, that stuff is more confusing than the multiplication outside. So we have two cases to graph y equal f of ax. We have two cases. First, if a is bigger than 1, shrink the domain a times. If a is less than 1, if a is a fraction, then we stretch the domain. All right. So this right here lists the 10 transformations we did last time, right? So if you go over them, try to tell me what to do. For instance, we say f of x plus 3, right? So I'm going to let you do it. F of x minus 3, right? F of x minus 5, f of x plus 7, okay? Negative f of x, f of negative x, and then we say, for instance, 5 f of x and f of 5x. Okay, go ahead, tell me, each transformation, what is each transformation we have to do? From, you know, what we did last week and you know, and just what you did today. For instance, f of x plus 3, what you have to do? The first one.
The first one's a y transformation.
Yeah, I
And
mean,
y-
so yeah, so what is exactly we have to do?
go up 3.
Exactly. So everybody write down the transformations here, everybody, before we go over them. Write the transformations that you think we have to do.
Is the f of x minus 5, is that one parentheses? Like, is it in the same one?
Yeah,
Or
yeah,
is
you are right to tell me that, because minus 5 confuses a little bit. It's only one parenthesis. Okay.
okay.
You see, all this section here is a note section. All this section is a note section. You know, we don't do a lot of calculations in that. We don't do. But in the test, for instance, I can ask you, okay, what is the transformation you have to do, etc., etc. I can give you like a very small graph and ask you to do a couple of transformations on that graph, okay? But it is a note section, you know, you should know until the end of the semester what are the transformations. Okay, so the first one is what? Yeah, how we go? Up what? Up 3, right? The second one, how we go?
Well, right 3.
Left.
Right 3, thank you. The third one, how we go?
Down 5.
Down 5. The next one is, we go?
Left 7.
Left 7, thank you. And the next one, we flip over.
Would you invert it?
Yeah,
or
we
not
invert
invert it,
over
you
what? Over
flip
what
it over.
axis?
X.
Over x-axis, right? The next one we flip over
Y-axis.
Y-axis.
y-axis, etc. Exactly. This one, what's going to happen to the domain or the range here? When you multiply by 5 outside, Everything
It's
that
going
is
to be
outside is about the range. We're gonna make the range 5 times bigger. We stretch the range. Okay? But look now, what's gonna happen to the domain here? Do you think the domain got stretched or got shrunk?
shrink.
Shrink the domain. You see, when the bigger the number is, the smaller the domain is gonna be. Okay, so these are the transformations, et cetera, et cetera. So now on my test, for instance, that's me, or on my test, I will not try to make it hard, stuff like that. For you, you have to know, at least know when to go up, when to go down, when to go to the right, when to go to the left, when to flip over x-axis, when to flip over y-axis. For the domain and the range, I do ask about them, but not a lot, okay? So that is, the parentheses. So now we can have symmetries, a graph, the graph of a function can have a symmetry with respect to the y-axis, okay? A graph, a function of a function is symmetric with respect to y-axis if this, when xy is on the graph, then negative xy is also on the graph. Okay? When xy is on the graph, then negative xy is on, basically, x and negative x share the same y, okay? That is when we have a symmetry with respect to the y-axis. So for instance, we got this one, for instance, you see this graph right here, x squared, for instance, this graph has a symmetry with respect to the y-axis. The y-axis is like a middle, it's like a mirror, you see? This y-axis is like a middle, okay? It's like a mirror. So basically, the two opposite axes, x, you see, this x and this x, they have the same y, right? Okay, so I ask you a question. I mean, this is just, when you look at the graph, you know if it is a symmetric or not, right? Can we have a graph of a function be symmetric with respect to the x-axis? Is that possible? Think about it.
I think it's not possible.
Yeah.
Yeah, why it would not be possible? Why? What would be the reason?
Oh, the vertical line.
Thank you very much, the vertical line test. Exactly. The graph of a function cannot be symmetric with respect to the y-axis, to the x-axis, because then it's gonna fail the vertical line test. You see, if my graph here is symmetric with respect to the x-axis, for instance, if this graph right here, you see, what's gonna happen? They're gonna fail what? They're gonna fail the vertical line test, right? Easily, okay? So the graph of a function cannot have that type of symmetry. Every time we say symmetry in math, it means we have one part is the same, it's like you have a mirror, okay? Every time we talk about symmetry, it's like we have a mirror, okay? So some other graph can be symmetric with respect to the origin. A graph, the graph of f is symmetric with respect to the origin to the origin if when xy belongs to the graph, negative x, negative y belongs also to the graph. When xy belongs to the graph, is on the graph, right? Then negative x, negative y is also on the graph. Okay, that is, you know, when you take the opposite of xy, you also in the graph. For instance, the graph of x cubed, for instance, this type of graph, for instance, this one. You see, this one is symmetric with respect not to a line, but as to a point. You see that point right here. So when you have xy, if this is x and this is y, then you have a negative x and negative y. They both belong to the graph. So are we planning to do a calculation with you know, with that? No. Just to let you know, okay? You know, unfortunately, we don't go deep into that. You know, in 163 we don't do that. It's just to let you know what we call symmetry, etc., etc. So we can have these two types of symmetries. We can have a lot of symmetries, you know, but they cannot contradict. They cannot contradict the vertical line test. If you have a symmetry, it cannot contradict the vertical line. All right. So now, and very, very lastly, what do we call an even function and an odd function? Again, these are two new concepts, right? An even function, because we are used the word, I mean, the word even, we know how to apply to numbers, right? We know what is an even number. We know what is an odd number. We know that. But now here we want to apply it to functions. You know, even function. An even function is when you plug in two opposite numbers, you get the same y. Is f of negative x is equal to f of x. That is what you call an even function. Okay, an even function is that function that does not care about whether you plug in a positive number or whether you plug in a negative number. It's give you the same y. Do you know an example of such functions? One example, can you give me an example of such functions? What the?
The square root.
The square root. You see,
Okay.
square root, if you put squares of 4 or you put squares of -4, you see, it will not give you the same answer. But close to square root, how about x squared, for instance? F of x equal x squared. You see, I never seen that, you know. So this might be something new on Zoom, saying that the meeting will end. Upgrade to Pro. Okay, that is something new. Okay.
Did you sign?
Yeah, I mean, that is the first time it happens. If it's something really new, then we have to upgrade to Pro. So I will have to, maybe then we will have to switch to go to Teams, maybe, you know. But we're gonna see and wait. If the meeting ends right now, I will try to log back to start another meeting, right? And we're gonna see what happens. Okay, this is about 20, 15. It's gonna be like maybe like 25, maybe 30 minutes they allow us to do. So if the meeting really ends, then maybe by next time we're gonna go to Teams.
Do you want us to put our names in the chat right now?
Yeah, for the attendance, yeah, please.
Okay.
I mean, so we're gonna try to log directly back on. I will try to log back on directly. See, I don't know what they say Pro, to upgrade to Pro, I don't know that. All right, so right here, let's try to Okay, you see, this is what you call an even function. For instance, if we say f of x equal x squared, right? F of x equal x squared. Why is this function is even? Why? Because when you plug in negative x, when you put f of negative x, right? F of negative x is negative x squared, right? Which is x squared, which is exactly f of x. So when you plug in a negative number, you plug in a positive number, you get the same answer, right? Can you give me another example that you think of, which is like a perfect square? I mean, which is an even function? Another example, very well known function. You see,
negative 5x plus 4.
Negative 5x plus 4. Okay, that function will not be exactly even because, for instance, right? For instance, if the f of x equals negative 5x plus 4, right? Just because it's an easy example, what is f of 1? F of 1 is negative 1, right? What is f of negative 1? It is 9. You see, they're not equal.
Yeah.
So for instance, how about f of x equal absolute value of x? If you have absolute value of x, whether you plug in a positive number or whether you plug in a negative number, what's going to happen? You're going to get exactly the same number, right? Same answer, same y. So
Positive.
Exactly, we get exactly the same thing. What we say here is x, y, and negative x is also for y, right? These two, they have the same y. So when you have an even function, the graph will be symmetric with respect to y-axis, right? The graph will be symmetric with respect to y-axis. Okay, that is an even function. Now, what do we call an odd function now? An odd function is when you plug in two opposites, you don't get exactly the same number, but you get opposite number. So f of negative x is negative f of x. That is an odd function. When I plug in two opposites, I don't get exactly the same number, but I get opposite numbers. For instance, f of x equal x cubed, you see? When you plug in two opposites, if f of 2 is 8, f of negative 2 is negative 8. You see, you also get opposite numbers, right? F of negative x is negative x cubed, which is negative x cubed, right? Which is negative f of x. So we have even numbers, even function, we have odd function. That is just good to know. Maybe you're going to see it on Alex, again, no, do we ask a lot about them? No, we don't, because we don't try to dig deep, 163, that is good for you to know. So we have, the graph will have a symmetry, will be symmetric with respect to the origin. All right. So basically, that was a section where we talked about, how to transform a graph. There was no calculation in this section at all. Almost we didn't do no, that's why the section is kind of boring a little bit because there is no calculation at all. Okay. So after that, we're going to do the section where we're going to do actually some calculation, some algebra stuff is the section that is called algebra of functions. So I'm anxious to see what's going to happen, If you're going to be allowed to come back to Zoom or not, etc. So algebra of functions.
I think it's gonna kick us, but usually it does that if you're not a membership, if you don't have a membership, it does that like if you have more than 4 people in a meeting.
Okay, so okay, normally, just right before your class, I had my other class, OED3 class, and we did the whole time. And it did not do anything. Maybe something they apply to CCBC today, maybe. I'm going to ask some other professors, and if there is no way to go around it, so we're gonna switch to Teams, right? So I think Teams will be okay for the duration of. I like Zoom because since the pandemic, I did my classes with Zoom, but if you have no choice, we're gonna go to Teams. All right. Oh, okay, so algebra of function, in this section right here, we're gonna see how to add functions, how to subtract functions, how to multiply functions, how to divide functions, how to compose functions. 5 stuff, right? Addition, subtraction, multiplication, division, and composition of functions, okay? So this is what you're gonna do in this section. First here, when you say addition, subtraction, multiplication, and division of functions. So if you say right here, if you have f of x, if you have 2 functions, f and g, f, g are 2 functions. Okay, what is the definition of the function f plus g of x? You see, what is the sum of the 2 functions? It is as simple as you can imagine that. It's just f of x plus g of x. The sum of the function sum is the sum of the 2 functions. That's it. The function sum f plus g is the sum of the 2 functions f of x plus g of x. All right. So, and f minus g